The purpose of this video is actually to give you a summary of what exactly are all these things and what is the important points. The important points are actually shown over here. If you just check it out, these are the few important points in this advanced materials. It's you have to calculate. You need to know how to calculate for your so-called how should I say, Young modulus of laminate, alright, and laminar, or in other words the ply, each of the ply. You need to know how to calculate that. You need to calculate its so-called safety factor using Zyhill, or if you need it, the max stress theory. So you also should also take note of the strain to failure. Alright, what type of strain will cause the composite to fail, or how do you analyze the strain to failure? We do have that in this playlist. And generally the first chapter, if you just check it out, is 1.2, 1. Whatever. The first few chapters is talking about how to define the directions. E1, E2 is directions, or how to define the general composites, or what are the equations that is generally needed in the future of laminates calculations. So all the basics are being explained in chapter 1 to 2. Meanwhile, the chapter 3 onwards is starting to talk about theoretical stuff, where what type of fibers are available for you, how do you choose the fibers, what are the fibers, how does the fiber being manufactured, and what are the applications for the different fibers, alright, and what opportunities of using the fibers to do something. So chapter 3 is generally talking about that. Similarly on the matrix also. So as you can see, these are matrices, alright. So nonetheless, chapter 4 will talk about the different molding process, alright, how do you create your composites. Alright, so as you can see, the first two chapters are introduction to calculating the stresses or the Young modulus or whatever thing that is needed for your composites. Then chapter 3 onwards tells you the what type of fibers and matrices do you have. And we focus on only thermosetting, we didn't focus on thermoplastic. Okay, so chapter 3 deals with the theoretical stuff on fibers and matrix. Chapter 4 talks about how to manufacture your composites, alright, and also deal with some tutorial questions. Chapter 5 start to talk about anisotropic and isotropic due to crystallized structure. So it's more on the grain structure type of thing already. And it'll give you a more introduction. So chapter 5 deals with the introduction to laminate system, or a composite laminate, where this is the laminate, and you may have different. I should say that a piece is a laminate. I should say that one piece is a laminar. Alright, if you stack along with another piece, another laminar, everything stacked together will become a laminate. This is the meaning. So in chapter 5 we only talk about just one ply laminar. Okay, so it deals with how to calculate the laminar stuffs, what are the Young modulus and things like that. Then chapter 6 we will go into slightly advanced. We mix the laminar together into a laminate and calculate the laminate strength and whatever to see whether is it good or not. Alright, so we deal with a lot of things for the laminate. And then after that we deal with the safety factor. After you calculate your stuff, you need to know what is the safety factor to prevent failure that may occur. Alright, and chapter 7, after knowing the laminate, then we will talk about chapter 7, where we use the laminate as the face of your sandwich structure. Alright, so your sandwich structure is somewhat like this is the face, this is the core, this is the face. So the faces will tell you will normally be used by laminate. So this is why we are moving towards the slightly more advanced again. Chapter 7 will talk about sandwich structure, how to analyze a sandwich beam. Alright, what is bending stress, shear stresses. It's quite detailed over here. And deal with the axial stiffness equations, ELX, whatever shear modulus. Axial stiffness is just telling you what is the Young modulus in the longitudinal directions, in the one direction or whatsoever it is. Okay, and how to get the Poisson ratios. How to calculate the Young modulus and Poisson ratio in a unique way, things like that. We will not go into details much because it's just a summary. Over here we do give you the understanding of what is Poisson ratios, like minor Poisson ratio and major Poisson ratio. Yeah, so this is the voice model rules of mixture. So just take note, we are come back to chapter 2 already. I just want to show you where is the Poisson ratio located at. Yeah, so this is the 1v2.9. Alright, so generally let's come back to chapter 7. We deal with the sandwich structure. Then chapter 8, we'll start to talk about applications of your composites. What are the case studies on composites. Then chapter 9 we deal with the failure analysis of okay, sorry, haven't yet. This is still chapter 8. Chapter 8 will talk about strain failure. Chapter 9 deals with the topography, talks about the surface like friction, wear, and everything. Like give you because normally a composite you need to have a certain surface finishing so that it protects the surface, while it also give you it prevents any wearing of the surface, so that it will not so-called tarnished or spoil your faces of your composite or whatever. So chapter 9 talks about that. Then chapter 10 will chapter 9 still talk about surface and then what are the equations to calculate friction wear or adhesive wear, abrasive wear, corrosion wear, erosion wear. So there's a lot of few things over there you should take note of. And then after which chapter 9 is pretty long, we deals with the co-working, what are the 3 categories of surface finishing. Alright, the cat 1 is to so-called you do surface finishing without altering any chemistry of the thing, but you do change the grain structure of your stuff. Then category 2 deals with changing the chemistry, like doing certain chemical stuff would change the whole chemical propositions of the materials. Then category 3 will deals with creating a coating on top of it, alright, and protecting it, protecting your wherever composites or your materials, even metals also. So summary of that, you should also just check it out if you need it. Then chapter 10 deals with the metals, alright, high strength low alloy metals, HSLA, okay, deals with that and tells you that what type of metals are really helpful for you in certain like enamel steels or duplex steels, or a different case study on the different surface finishing, or what type of steels is needed, or if it's chlorine base, prevent cracking, prevent corrosion, stress corrosion, cracking, everything. You can use duplex rather than enamel. Alright, and then why is it so? It deals with the perlite and cementite, which is something more deeper. Alright, and these are the things. And then we do some tutorials. At chapter 11 deals a lot of tutorials, and at the end of the day we will have a here and there type of brief explanations, just to touch up on the things that is not being so-called well done in the videos. So all in all, these are the things that give you a full gauge on generally it's very useful. It's a very useful module. So you kind of learn a lot of things. So I think that's all. If you want to know more in the future, then you just check it out. Just give it a look and see how it goes. Okay, maybe I should add in a little more, because I haven't actually touched up on the thing. Alright, there will be a ceramic I haven't uploaded yet. So although there is a ceramic, but my explanation sucks over there because I never put efforts to do that. I'm just quickly showing the equations and that's all. So metal HSLA, what type of surface finishing, alright, to protect metal or composite. Alright, yeah, and then different, yeah, I think that's all. Metal HSLA, yeah, applications. Alright, then shape memory alloy, more metals, yeah, which chapter 10. Yeah, and super elastic, nickel titanium alloy, these are the keywords. So I think this is it lah, and yeah.